Hello everyone and welcome to this Android application development lesson 1 Android application framework. My name is Tawqir Faz and I'm Android certified trainer holding a master's degree in computer science. I have more than 10 years of consultation experience with public and private sector. You can follow me over the LinkedIn. My LinkedIn address is given here. And my email address is for further communication tawqir98@hotmail.com. This is my email address. You can follow me over the email address as well. Now, before proceeding any further, the prerequisite for this course is one should be familiar with the Java fundamentals for Android application development. And if you are interested to look for the exam as well, there are two kinds of exams available from the different awarding bodies. One is Android ATC and the other one is from Google. Let me just take you to those two exams where you can register for the exams and you can look for the certificates also. One is Android ATC. You can see it over the screen, androidatc.com, and you can find the Android certified application developer exam as well. So exam cost varies from awarding body to awarding bodies. So this is one of the Android ATC stands for Android Advanced Training Consultants. So you can register your exams after completing this course, and Google also offers some kind of certifications on Android as well, and the Google certification is Associate Android Developer. So after completing this course, you can either register yourself for Google certifications or for Android ATC certificate. So let's start again. So these are the different Android certifications paths which are available. One is from Google and other one is from Android ATC. The prerequisite for this course, before starting this course, I assume that you are familiar with the Java fundamentals. All participants should know the fundamentals of object-oriented programming concepts using Java, and you should be familiar with the Java SE Standard Edition 1.8 or and above, and one should be familiar with classes, control flow, inheritance, instantiation, initialization, assignment, methods overloading, and method overriding. These are the concepts which one should be familiar with before starting this course. These are the prerequisites for this course. Now, who should attend this course? This course is intended for software developers interested in developing mobile applications and supporting the famous version of Android like Jelly Bean, KitKat, Lollipop, Marshmallow, Nougat, Oreo, and Pie. Here comes the supplementary material. Before starting this course, you should install Android Studio 3.3, the JDK and the JRE Java Runtime Environment and Java Development Kit 1.8 should be installed to your computer, and you should download and start the Android emulator as well. Now, these supplementary materials I have recorded another video for this. You can please watch supplementary material video where you will be guided how to install Android Studio 3.3 and how to install JDK and JRE to your machine and how to run Android emulator as well. Now here is the knowledge check. What is the prerequisite for this course? So the option A is HTML and CSS3, option B Python, option C Java, option D all of the above. Yes, you are correct. Option C, which is Java, that's the prerequisite for this course. Let's move on. Here is the course contents now. Lesson 1, there are 10 lessons for this course. Lesson 1 is related to understand Android packages, API levels, application lifecycle, components, and log messages. Lesson 2 is related to designing application interface, use of different layouts. Lesson 3 is working with Android list and views. Lesson 4 is switching between different activities, sharing information through intents. Lesson 5, we will discuss about custom views, dialogues and toasts. Lesson 6, we will discuss about data persistence, how to store data and how to retrieve information and how to save files to the Android device. Lesson 7 is working with the navigation drawer and web views. Lesson 8, networking, consuming web services using HTTP, consuming JSON services, socket programming. Lesson 9 is related to content providers, SQLite database, and lesson 10 is Android notification and publishing your application to the Google market. Starting with this lesson 1, in this lesson, our main focus will be to understand what is Android package, what are the different API levels, Android application or activity lifecycle, components of Android application, Android log messages, and in the lab 1 we will be discussing, I will demonstrate the activity lifecycle in an Android application. So let's start with lesson 1. Lesson 1, we are starting with the Android packages. Whenever you create any Android application, the first and the foremost important thing is you need to give the package name. And remember, there are rules to define the package name. The first rule is the package names are written in all lowercase. And here is the good practice to define your package name. Always reverse your domain. Let's suppose you are owning a website of souk.com. So the reverse of that package name could be com.souk.the application name. Or if you have a website called example.int, so the suitable package name for this application could be int_example.the application name. Now, why is it important to reverse the package, the domain name? Actually, whenever you are interested to upload your application to the Android market or the Google Play Store, you see there are millions of applications already uploaded to the Google market. Now this package name makes this application unique. That's the identifier your application should contain. So that's why to make this application unique application from any other application, that's why it is a common practice to reverse the domain name of your application. So that's the good practice, that you should give the package name, reverse the domain name of your website, and then gives the last part is the application name. So I'll show you in couple of minutes when we will create our application. I'll show you how to give this package name also. Now next is the API level. API stands for Application Programming Interface. You see there are different versions of Android application, Android platforms, starting with Froyo, Honeycomb, Gingerbread. I'm not giving those names in order, but you can follow, you can see this, ice cream sandwich. There are the different versions of Android platforms or Android versions. Now with the development of these different versions, every time whenever they added a new feature into Android version, they increase the API level. Now what does it contains? The API level, it contains the set of packages and classes, a set of XML elements and attributes for declaring a manifest file. It contains a set of XML elements and attributes for declaring and accessing resources, a set of intents, a set of permission that application can request, as well as permission enforcement that includes in the system. So these are the things which are incorporated in different API levels. So don't worry about it. I know you must be confused that what are these API levels and what is their use. With the passage of time, as you come along and you develop few applications in Android, you will be very much comfortable with these API levels as well, and you will have a better understanding of API level. Here comes the different platform versions of and API distribution. If you see the 4.1 here is ice cream sandwich, and the API level here is 15. Let me just change this to different color. Next is, you see, API level here is Jelly Bean 4.1 and it is 16 here, and 4.2 17 API level, 18 API level for Jelly Bean, and Kit Kat 19, Lollipop 21, Lollipop 5.1 Android platform version, it takes API level 22. 6.0 Marshmallow takes API level 23, 7.0 Nougat API level 24, 7.1 Nougat 25, and 8.0 Oreo takes 26 API level, and 8.1 Oreo takes API level 27. Now let's suppose whenever you create a program in Android Studio, it will ask you what is your minimum API level. If you select the minimum API level here, 4.1 Jelly Bean, so it means, what does this mean? The cumulative distribution of this API level is 99.6, almost 100%. All of the users can install this application to their Android platform. If you are interested to get more information about this API levels, please follow this link, developer.android.com/about/dashboard/index.html. Let me just take you to this API levels. Here you get the distribution, the API level. This is the Android developer website where you get most of the information related to Android application development. Well, by the way, this website is very useful if you are working as a developer, so you will get all of the documentation related to Android application development. You can get the information using this website also, developers.android.com. So here is the knowledge check. Which is the Android version for API level 21? So A Marshmallow, B Nougat, C Oreo, D Lollipop. Yes, your guess is correct. It is D Lollipop. And we can double check this one also. Let's go and see. API level 21 is Lollipop here. So you can get this also information from the developer website, and there's no need to remember these API levels, because when we create a program in Android Studio, all this information is already given there, and you need to select the API levels according to your requirement. Here comes the application lifecycle. Lifecycle is controlled by the Android framework itself. Applications are always listening to changes in its state and respond accordingly. There are 4 main states of an application. State active. Active means the application is visible, focused, and you are interacting with that application. State paused, visible yet not focused activity. And state stopped, when an activity is not visible, it goes to the stopped state. And inactive, after an activity has been killed and before it's been launched, it's inactive. Let me show you the life cycle of this application. Suppose if I tap on Gmail. So when I tap on the Gmail, now this Gmail activity is active. Now if I click the back button, now it goes into the paused state. If I open it again it becomes active. Active means it is focused and the user is interacting with this application. Paused means it's in the background, it's not active. And after some time, just to make the good use of these resources, the Android operating system will decide to kill this application in order to give more space to other applications, so that application becomes inactive. Well guys, if you are interested to register for the exam, then you should be familiar with this activity life cycle in Android application. This diagram explains you everything, and there are few questions related to this activity life cycle in Android application. Whenever you tap, let's suppose this is the Android emulator, whenever you tap an application, now there are certain number of methods which are being called in the background. So whenever you tap an application, the first method which is being called is onCreate method. In this onCreate method, all your controls like button, like edit box, like text box, labels, drop down boxes, all these controls are initialized in the onCreate method. Once the onCreate method, after calling this onCreate method, then the next method which is being called is Onstart method. In Onstart method, we need to initialize some of the sensors or some of the components which our application is going to use. Say for instance, if you are going to use the fingerprinting sensors, then you need to initialize that fingerprinting sensors in the Onstart method. And if you are going to use the camera feature in your application, then you need to initialize your camera feature in the Onstart method. OnResume method, next is the OnResume method. When your application becomes active and you are interacting with that application, OnResume method will be called, and till this application remains on the screen and you are interacting with this, OnResume method remains on call. And when you press the back button, the first method which is being called is onPaused, and from onPaused, next method onStop method will be called. Now here in onPause and onStop method, if you are using some resources like camera, like any download background activity which you are downloading something, you need to explicitly stop those components. Like if you are using camera feature here, you need to stop this camera feature, otherwise that application will take that resource and other application could not be able to use that resource. So in onPause and onStop method, we need to terminate those background processes as well. And onDestroy method, the Android system will call this onDestroy methods. The Android system will check within the 5 seconds if you are calling this activity again, then from onStop again from onStop again on restart and onStart and onResume method will be called, and from onPause directly onResume method will be called. But for the 5 seconds, if your application is not being called again, then Android, as you know, the device is having low specifications, low memory, so in order to give optimum performance, Android operating system will kill that application by calling the onDestroy method. So within the 5 seconds, if the application is not called again, then onDestroy method will be called automatically. Don't worry about these things. I'll show you the demonstration how these methods are being called one by one in a sequence. That will be our lab session in which I will demonstrate you how these methods are being called. Now, before proceeding any further, here is a knowledge check. This kind of question is given in the exam as well. If you are registered for exam, so you should prepare for the exam also. So here is the question now. Which one of the following is the correct activity life cycle? The sequence. Option A, onCreate. First onCreate method will be called. onCreate method will be called. Then onResume. Then onStart. Then onPause. OnStop method will be called. Option B, onCreate, onStart, onResume, onPause, onStop method will be called. C, onResume, onStart, onCreate, onPause, onStop method will be called. And D, onCreate, onStart, onResume, onStop, onPause, method will be called. So which one is the correct option? Here the correct option is option B. On create method will be called, then on start method will be called, then on resume, on pause, and on stop method. That's the sequence which is to be called here. So that's the correct answer, the B. So next important concept which I'm going to discuss with you is the components of an Android application. Well, there are other components as well. I'm going to discuss the most important components which we will be dealing with. And the first and the foremost important concept is activities. Suppose you are creating a website. In a website, the page which you interact with, let's suppose this is the page you interact with, we call it a web page. If you are having a desktop application, there we call them the forms or the windows. But here in Android, these applications, when I click on the application, these applications, the screen which you see on top of it, this screen is basically called an activity. Let's suppose we have the first activity. If I click on this button, and then it takes me to another activity now. So basically a screen having different controls is called an activity here. We don't call it a window, this one, and we don't call them a web page. We call them as activities in Android. Next component which is available in Android application is services. A service is a component that runs in the background. And most important thing, and to perform long running operations or to perform work for remote processes. The most important thing is a service does not provide a user interface. That's the important thing. For example, a service might play music in the background while the user is in a different app, or it might fetch data over the network without blocking user interactions with an activity. Another component such as an activity can start the service and let it run or bind it to it in order to interact with it. So remember, the services are the background activities. Another component of an Android application is the content provider. A content provider manages a shared set of application data. You can store the data in the file system, an SQLite database on the web, or any other persistent storage location your app can access. For example, the Android system provides a content provider that manages the user's contact information. As such, any app with the proper permission can query part of the content provider to read and write information about the particular person. So these content providers can take the form of saving files on a device, SQLite database, a built-in database to keep the records of users' contact information, and downloading information from the internet. So these content providers are very much used, and we will have some demonstrations of SQLite database and saving files in upcoming videos as well. Another important component of Android application is broadcast receivers. A broadcast receiver is a component that responds to system-wide broadcast announcements. Many broadcasts originate from the system. For example, a broadcast announcing that the screen has turned off, the battery is low, or a picture was captured. Apps can also initiate broadcast, for example, to let other apps know that some data has been downloaded to the device and is available for them to use. Although broadcast receivers do not display a user interface, they may create a status bar notification to alert the user when a broadcast event is occurred. So we will discuss more about on broadcast receivers when we discuss the notifications section of our videos. Next is the Android log. Generally, we can use the Android log methods to write logs information. This logs information is useful for the developers, not for the users. So the developers can use this Android log for the debugging point of view. We have different kinds of logs information. Log.v, v means for verbose, log.d for debug, log.i for information, log.w for warning, and log.e for error. We use this in our Android application development. So it has nothing to do with the functionality. It helps the developer to debug their programs, Android applications, very much. So the syntax for this Android log is log.i means information. First comes the tag could be the key as well, and next comes the message now. And you can see the logs information in the logcat window as well. So let's start now the first Android application let's develop the first Android application, and we will understand in this demonstration, we will understand the activity life cycle. So I have already installed Android Studio to my computer, so please follow me in other separate video in the supplementary video materials, where you will find how to install Android Studio, how to install JDK and JVM, and how to run the emulator as well. So I'm going to start with the new program, start a new Android Studio project here, and these are the different templates which are available to start a project. Right now we will be discussing all other templates as well. Right now I'm going to start with the empty application. Click next, and then we need to provide the name. The name is, let's suppose, the life cycle. And here comes the package name. You remember I discussed with you the package name here when we start our course. Here is the package name. You need to reverse the package name of your Android application. So let's suppose this is an example. So I have a website called example.com. So the opposite could be com.example.lifecycle. Here is the save location where you want to save this information. And the development language, there are two development languages. One is Java and other one is Kotlin. I'll be working with Java. Kotlin is a new language, and the overhead of this Kotlin language is you will find a very low developer community, so you will be getting less information on Kotlin. And if you are familiar with Java, believe me, the transition will be very easy for you to move from Java to Kotlin language. Here comes the API level, the minimum API level, as we discussed. If you see, we discussed these API levels now, so you don't worry about to remember these API levels. Android Studio will help you to select a proper API level. Here we have different API levels here. So which API level do we need to select for? Let's suppose if I select API level 16. If you select API level 16, almost 99.6% of the devices can install this application and can run this very well. But remember, the important thing over here is if you select the lowest API level, it may increase the size of your application, because for the backward compatibility, it has to attach lots of libraries in your project as well, which will increase the size of your application also. So you need to be wise to select the proper API level which the user will be using this application. So for me, I'm gonna pick the API level. I think I'm comfortable with API level 18 onwards, or let's make it API level 20. Okay, API level 20, Android 4.4, KitKat Wear. So if you want to get information on these API levels, you can click on help me to choose, and the diagram which I explained in my video as well. You can find this, you can get the information by clicking on that particular API level. It provides you what features this API is going to provide you related to restricted profiles, wireless and connectivity, multimedia, graphics and all. So you can get this all information here, and you can follow this link to get more information over the developer website also. Next is, this project will support instant app. Now what is this feature? Sometimes when a user wants to know about that application, instead of installing the full version of the application, they can instantly check the features of that application. If you check this box, this project will support instant apps, this will really help them to instantly check the feature, check the functionality of that application, instead of installing the full version of that application also. So I just checked this one, so to support this feature as well. Click finish. Now just wait for some time, because Android Studio takes too much time to initialize different resources here. So I hope that we will quickly get an access to. Yes, now there are many folders here. I'm not gonna discuss all these folders right now, because with the passage of time, as you come along, all these folders will start making sense to you, because I'll be explaining these folders one by one. Now the most important thing over here in this project is, you should understand main activity, which is the main activity Java file, and the XML file of your interface. Now this XML file is also called the interface as well. Let me just increase the size, go to zoom in. You see this one, activity underscore main.xml, and here comes the Java file here. So I have already installed the emulator, and the emulator is also running here. Okay, in my separate video I explained how to install and run this emulator as well. Now let me run this application and see the output, how it appears now. So I clicked on this run button. When you click on the run button, it will ask you, if you are running multiple emulators, it will ask you which emulator you want to run this application on. I want the selected emulator. If I click on OK button, this application will run on the selected emulator. So let's see. Here goes this application. Now you can see when we run this application, it shows me hello world application here. So as we were discussing about the application life cycle, let me show you these methods, how these methods are to be called one by one. If I go to my Android Studio, see which method is being called here, onCreate, and here in onCreate method we are calling the XML, the layout information. This layout information contains all the controls here. So here I'm gonna call those methods which are being called in the background one by one. So to generate those methods, you can right click in this editor, click on generate button, then click on override methods, and in override methods we have the list of those methods available: on start, on stop, and you can look for all other methods as well. So let's suppose, first of all, I'm gonna call it onStart method. Click OK, and here goes the onStart method here. So I want to start with the log information. So I want to display the log information that this method is triggered. So what we will do, we will call it log.i. Remember, log.i means it is an information only to the users. So the first one is the tag information. Here the tag, it is a string, and the tag information which I'm gonna write is, suppose we can call it a test, comma, then comes the message. Now in the message, what information I'm gonna give? The onStart method triggered. So I'm gonna display this message over here. Now outside this one, I'm gonna call all other methods. What next method will be called after the onStart method? If you see here, after the onStart method, onResume method will be called. let's write that information also. Either you can generate that method, you can click on right click over the editor, click on generate, override methods, and you can look for on resume. So let's go down, on pause, here goes the on resume method. Click on resume method, and I'm gonna write the same log information here, log.i, and the tag is the same, test, comma, and the message could be on resume method triggered. So what is the next method after on resume? That is the active application. The next method which is gonna be called is on pause. We can simply write it also here, on pause. Here goes the on pause. To complete this message, press the tab key. So I press the tab key here to complete this message. Click in the end and then type this log.i. Again, my tag is test and the message is on pause method triggered. Now after this on pause method, what is the next method which is to be called? On stop. So I can simply call it on stop. Use tab key to complete. Press enter to insert a new line, and then you can write here log.i, and the tag is again test, comma, and the message could be on stop method is triggered. So let's write it here, is triggered. Now after on stop method, what will be the next method to be called? On pause, on stop, on destroy, on destroy method that is being called now. So log.i, and the test will be the tag, and the information which we want to print here is on destroy method is triggered here again. So let's run this application and see how these methods are being called. And remember, the output will be generated in the logcat window. Let me run this application, the test application. So it should run on this emulator. Click OK and wait for some time to generate the output here in the emulator. And we will be looking, see the application is loaded in the emulator. We need to go to the logcat window. You see down there in the Android Studio there is a logcat, and you see we have hundreds of logs information generated here in the logcat window. How can we see our own test log information? First of all, from here you can change this to info, because our log.i means information, and you can look for the tag. What is the tag information here? You can look for that particular tag here, which is test. Type this test and press enter. See which method is called first, onStart. Though we have not mentioned here in the onStart method, we have not given any log information, otherwise it should have called in the onCreate method first. So onStart method is called first, and then onResume method is called. It means our application is running here and it is focused and the user is interacting with this application. Now if I click on the back button, see on pause method is triggered, then on stop method is triggered, and on destroy method is triggered. Just to, because the Android device has a lower memory resources, just to get the good performance of your Android device, the Android system will automatically kill that process if it is no longer needed. Now if if you run this application, let me go again. My application name is life cycle, so I'm gonna tap on the life cycle application. Sorry, on start method is called, then on resume method is called. Now if I click on the back button again, so on pause method is called, on stop and on destroy method is called. So in the background, every application, whenever you create an application, all these applications, they are calling these methods automatically in the background. So our main focus will be in the on create method, but in some applications like to use camera feature or to use the fingerprinting sensors, we may be working with on start, on resume methods as well, or in some database kind of applications we will be using on start and on resume and on pause methods as well, right? So I hope you understand the concept here, the concept of log information, and the concept of activity life cycle, the concept of on start, on resume, on pause, on stop, and on destroy methods. So that's the activity life cycle in an Android application. I hope that you like this video and keep watching, keep learning. See you in the next video. Thank you very much.